Hello everybody, my name is Matthias Sohn. And
I'm Adel Zaalouk.
So we're working for SAP and we want to present Gardener, which is a service we implemented in open source to manage Kubernetes clusters. So let's start from containers to Kubernetes. Who is using containers here? Everybody. So you know how containers work. So we have a VM. On top of that we have a host OS, container runtime, and then we add containers on top. So what are the benefits? They provide isolation, so we get small containers running a process, and they're each one isolated from each other. We have immutable infrastructure because those images are immutable. It's portable, so we can run it on different underlying infrastructure. Deployment gets faster. We can version those containers. And this makes it also easy to share the containers between developers, or you can use the same container during development and during production without changing anything in between. But there are also challenges. I mean, a single container can do something for you, but typically you need more than one, and then challenges come. So you need networking. If you run them on different hosts, you need to care about deployments. How do I deploy all my microservices? Those services need to discover each other, so you need some mechanism for that. You want auto-scaling in the end, so that you can react to different load. You need to persist some data, and you need to take care of the data so that you don't lose it. You need some logging and monitoring if something goes wrong. And of course, security is also an issue. So if you build an application from microservices running on containers, security is a big topic. And here container schedulers come to the rescue, so they try to solve those challenges. So we have Docker Swarm, we have Mesos, and we also have Kubernetes, which we will talk about. So what is Kubernetes? It's orchestrating a cluster of containers which runs on different hosts and some data center. So it cares about placing the workload on the right node. So if a node is already full, you can't place more containers there, so you have to choose a different node. It cares about networking, so all the nitty-gritty stuff of programming the network is covered by Kubernetes. It can handle deployment, so you can assemble an application from many services and deploy it at once. It helps with the auto-scaling stuff. It also helps to roll out your application or roll it back if the new version doesn't work. You can also implement something like A/B testing. The basic principle of Kubernetes is it's a declarative environment, so it's not procedural. So you describe what you want. Let's say you want a deployment, so you describe it in YAML. You throw this into the Kubernetes API server, and then Kubernetes will care for the rest. So you declare the target state, and it will reconcile to the desired state. And this is self-healing, so if something goes wrong, Kubernetes will try to fix it at one time. And Kubernetes helps to port your workload between different infrastructures, and there are also multiple container runtimes available. So many interesting features. So, but what does Kubernetes not cover, at least at the moment? Installation and management of clusters, especially if you have many of them. So currently, if you take Kubernetes, you need some additional tool to install it. And also, if you're not just bound to one infrastructure, but you want to run on different infrastructures, this is getting more messy. So we want to run our stuff on public cloud providers, but we also have customers who want to run the same software on private cloud. And we want to go one step farther. So we want to go from DevOps, partially automated in Kubernetes, to zero ops if possible. I mean, there will be always some edge cases. So we target minimal TCO. We also want to manage the nodes from Kubernetes, which is currently not the case. We also want to manage the control planes of the clusters where the applications run. And we want all the day 2 operations, so the updates and stuff like that. And for that, we started the Project Gardener, I think 1.5 years back. This is open source, you can find it on GitHub. And what do we want to achieve with the Gardener? So we want to provide and establish a solution for running Kubernetes clusters as a service. So the first one is we want central provisioning, so we want to have one place where we can manage all the clusters from. We want to establish a solution not just in SAP but in the community, so we engage with, we made it open source. We try to foster adoption and find collaborators. And finally, the target is to become a CNCF project to really embed it in the community. And finally, the biggest requirement for us is that we need to manage many clusters. We have many customers. And we also, there are different reasons why you may need more than one cluster, and we want to manage them all in a good way. We want to do this homogeneously on the different providers and also in the private cloud. So we want to provide full control of Kubernetes to our users, be it SAP applications or customers using the clusters, and this should behave homogeneous across the installations, across the infrastructures. So currently we support AWS, Azure, GCP, AliCloud, and OpenStack, which is our current solution for the private data center, and eventually we will also implement bare metal support. And finally, we have this target that we want to shrink TCO and go from DevOps to hopefully almost zero ops. And support all the kind of day 2 operations. So we want to support backup and recovery fully automated. We need high resilience and robustness. We want self-healing for all aspects, and auto-scaling, of course, for reacting to the load and optimizing the costs. And we want to also manage rollout of bug fixes, security patches, updates, whatever, certificate management. All the tricky stuff, which is a lot of work if you have to do it by scripting or stuff like that. So that's finally the mission of the project. And now let's look into what is the basic architecture principle. So we try to follow how Kubernetes works. So it's a system for automating deployment, scaling, and management of containers in the end. So what we do is we use Kubernetes to deploy Kubernetes clusters and manage them. And the control planes of most of the clusters we also run in Kubernetes. So we use also the Kubernetes functionality to keep those control planes up and running. And it also saves a lot of resources. So let's look at a traditional Kubernetes setup. So we have clusters. You see those green boxes here. These are hosting the control planes. Typically you have an HA setup, so you need multiple nodes for that, and you have workers which run the actual workload you want to run. So now let's look at how we do that with Gardener. So we have a Gardener cluster, that's a central one, which orchestrates all the other clusters and manages creation and updates and so on. And from the Gardener cluster, we spin up a seed cluster. That's typically one per infrastructure and data center, so that we have a close by cluster which is near to the workload. And then we can spin up shoot clusters just very easily. Strangely, those shoot clusters, they seem to have no master nodes. That's also true. If you look inside the worker nodes of the seed, then we see that the control plane, so that's etcd, that's key value store, where all the configuration is stored, the API store, controller manager, scheduler, and so on, that's all deployed in Kubernetes. So it's not running directly on a node, but it's running in Kubernetes. And if something goes wrong with the control plane, this cluster will care for self-healing, so it will fix it. It will restart the respective pods, for example. And then we do that for all those shoot clusters. So those are the clusters where in the end the workload will run. So all the applications and stuff like that. And in addition, this is not on the diagram, we have a machine controller manager. This is another Kubernetes extension. which cares about machine provisioning, self-healing, auto-update, auto-scaling of the nodes underneath the Kubernetes cluster. So it's not only about spinning up the clusters, but also scaling up and down the machines underneath, which is currently not part of Kubernetes. So it's an extension. The primary design principle of Gartner is we don't want to reinvent the wheel. We let just Kubernetes drive the design. So what is the core definition we need for a new cluster? That's a cluster resource. So you can, it's just a YAML file describing a cluster. That's a custom resource. So it's just extending the resource model of Kubernetes itself. Then you can define which DNS to use. You can define your network sitter. You can you specify which worker pools you want to have. You specify the Kubernetes version. You can also tweak it, so you can tweak configuration of the control plane. And you can also define when you can accept updates of all the software running in your cluster. And finally, Gartner will later on, when you deploy this into Gartner, it will spin up a cluster looking like that, and it will report back the status here. So the Gartner will take this, and then it can deploy it on all the supported infrastructures. So you just need to provide credentials for one of those, and then you can deploy a cluster in that. This is a architecture diagram. So on the left-hand side, we have the Gardener. So we have a command line tool. You can also use kube control to control it. We have the Gardener clusters control plane. And then most importantly, we have the Gardener API server, which is an extension to the Kubernetes API server. And we have the controller manager, which does the reconciliation. So you describe a cluster, and the controller will pick up this definition and make it reality. So it's reconciling the state. If you later on change it, then it will adapt the cluster accordingly. And we also have a dashboard so that you can also see your clusters. Then we have the seed clusters. They run. The main purpose of them is running the control plane. So for each control plane of the shoot clusters, we spin up a Kubernetes control plane. And then finally, the Gardener creates the shoot clusters. So it will create all the necessary infrastructure there, and then it will deploy another control plane in the seed cluster. Gardener uses many Kubernetes artifacts to implement all that. So we try to really use Kubernetes wherever possible. So all the usual Kubernetes building blocks we use, like pods, replica sets, and deployments to do deployments. To deploy containers, load balancers for accessing the containers. We use jobs. Of course, config maps and secrets for configuring everything. Then regarding persistence, we use persistent volumes, drivers, and stateful sets. Reconciliation is the overall principle of how the API works in Kubernetes. So we have CRDs, those are the custom resources, and controllers which do the reconciliation. And finally, we implemented Gardener as an API server extension. And of course, we also need security, so we use admission control and role-based access control. And on top of that, we use Helm for deployments, add-on manager to install additional software in the cluster. We use Calico as for the overlay networks, network policies to tighten security. And for managing all the certificates, we use SAP Manager and SAP Broker. And we use Cluster Autoscaler to do the autoscaling, both from doing horizontal and vertical report autoscaling, and also to do node autoscaling. And for monitoring, we use Prometheus, and for logging, we use a standard Elasticsearch stack. On top of that, we have the workload. So in the demo, you will see as a workload, we will deploy EclipseJ. now where do all these clusters come from? For the garden cluster itself, you need some Bootstrap cluster, so you can either use one of the GKE or EKS cluster, for example, or we have a Kubify tool which is based on Terraform, which can also install a Bootstrap cluster. And later on we will have some disaster recovery setup which is not yet ready, so that's in planning. And the seed clusters are created as shoots of the gardener, so they will be managed by the gardener itself. And then from the seed we can spin up the shoot clusters. So they are created by the seed clusters and managed by the gardener. Okay, so this was the introduction, and now Adel will show the demo.
Cool. All right. So Matthias have explained already what Gardener is. I think I have to exit out of here. Yeah. So basically, this is what the Gardener dashboard looks like. So you have the option to create clusters. I have already created some clusters. I see some people. Yeah, the font is not really good, but you can see here we have. Yeah. We have 2 GCP clusters and 1 AWS cluster. And if you notice also, there are different versions. So 2 of them are 1.10 and one of them is 1.11. We're gonna upgrade later to the different versions. So creating a cluster with Gardener is really simple. So you just go here and you can specify, okay, my cluster name is hello, Eclipse, okay, hello. And then you can specify, okay, what cluster type do I want? We support currently AWS, Azure, GCP, OpenStack. In the future, we will also be supporting Ali Cloud, which is very soon. And of course, you can also specify your worker settings, how much RAM, volume sizes, and so on. You can also specify the maintenance time window. When is it okay for you to have your Kubernetes cluster maintained? Usually this is AM. So that's basically it, and then you press create. I'm not going to do that because the cloud is not really, the connection here in the conference is not that strong. So we've already created these clusters, and what we're going to do is we want to dig deeper here. Who here uses Kubernetes CLI every day? Okay, not much. I don't like typing commands either, so what I did is I wrote some bash functions that basically does what I want, but it will also show you the commands. So what we want to do is we want to show our Gardener components. So I will go back to this figure because I'm not sure you grasped it the first time. Matthias have forged a lot of effort to make this figure, but it's basically everything that is in Gardener. It's I wouldn't say as simple, but it's everything there. So the Garden cluster is what we're going to focus on at the moment, and it's containing of the Gardener dashboard, the API server, and the controller manager. If you're not familiar with Kubernetes, an API server is basically where you define your admission plugins, you define your resources, the services, and so on. And the controller manager is basically where you define your controllers. You watch over any resource being created, and you take action to make the state defined happen. Right? And Gardener exactly follows these same principles. It has a Gardener API server and it has a Gardener controller manager. So when you look at the Kubernetes architecture in Gardener, it's pretty similar. So remember the first part? Okay. Now we're going to see this live. So basically this is the Garden cluster. And the 2 important components that we want to look at is the Gardener API server and the controller manager. Yeah. And these are the services that we define. So these are custom services. We define our own group. And then these are the resources exposed. And the resources that we have seeds, shoots, secret bindings, projects and quotas, and cloud profiles. Basically, shoots are your interface. This is where your workloads were run. And seeds are our control plane, where we keep your control plane, the API server, the scheduler, and everything else. If you have any question in the middle, just ask or you, yeah. Yeah, and then basically what we want is we want to look also at the seed cluster. So you can also see the seed. We're going to show the seed on an AWS because we host the our shoot cluster control plane on the AWS seed. All the shoot clusters, AWS clusters, are hosted on the AWS seed. And again, we highlight this second area. What we're going to see is we're going to see the etcd, basically the storage stack. We're going to also look at the monitoring stack, which is basically Prometheus and Grafana we use for the graphs. And we have the controller manager and the scheduler and the machine controller manager, which we will see at the moment. All right. So we see it again. So this is a seed, and this is the etcd. We have two etcd, one for the events and one for holding the actual resources. And this is our control plane. So we can focus on the Kube API server and the controller manager. This is basically exactly the control plane of a normal Kubernetes cluster, but we host it on the seed. And we have the machine controller manager. And the machine controller manager is a very nice addition. What it does is, instead of you writing cloud provider specific code to create machines or to create VMs, we have defined these as Kubernetes resources. So you can actually do something like get machine. We show you what a machine is. We can also, it's very similar to a deployment, a pod, and a replica set. A deployment is controlling a replica set, and a replica set is controlling the pods. Exactly the same. So here, if I say machine deploy, I also get a deployment. We can also have a look at it. Let's say, yeah, so yeah. So here you see I define how many replicas I want, and basically, yeah, the kind is a machine deployment. It's a custom resource, and I define how many replicas I want, and the strategy rolling a bit, exactly like if you look at a deployment. So we basically use exactly the same principle for creating the machine controller manager. And on top of that, which I will not talk much about, is the cluster autoscaler, which detects when your cluster is on load, and then it modifies these number of replicas here automatically. You don't have to do anything. You just enable it, and it does it for you. Okay, cool.
One short question.
Yeah.
How about the VPC? Is that also modeled like a Kubernetes resource here?
No, everything is abstracted in the machine controller manager. So we support all the cloud provider and the machine controller manager. You don't really interact. You don't write cloud provider specific code. So if I want to create a VPC, I don't say create VPC. I basically say I want to create a machine on AWS and I specify the resources. But we have another project called in the future called Graph that will actually help you interact directly with Kubernetes resources. But it's not really something that we should talk about here, because you're going on a different layer on the abstraction. Here it's very abstracted. It's nice. Just define, yeah. You don't have to memorize all the settings of a cloud provider. So maybe I don't know what a VPC is, right? So I don't want to do this on a. Yeah, and this is basically our monitoring and logging stack. We have Alert Manager, Grafana, and we have Prometheus. And now let's have a look at the API servers, and now I will try to kill them. Now it's terminating, but it will spawn very fast, because this is, again, the same Kubernetes concepts. It's a deployment. It looks at resources, watches for pods, finds them not available. It spawns new ones. So basically, exactly the same principle. At the end of the day, we will have 4 pods, again, functioning in a very short time.
So it's fixing itself.
Yeah, it's self-healing. And this is not something that we invented ourselves. We're reusing Kubernetes concepts in Gartner. Yeah, so you see here, 41 seconds, 40 seconds, 40, yeah, all these are new ones. So now all the new ones are running. You can also try to kill etcd. Let me first just a little bit put this down. I think that is better. etcd. Yeah, so I'm killing the etcd pods, the main and the persistent volumes that source the data. So it's terminating. Now it will respawn because we have a concept of snapshots. We snapshot the etcd every now and then, so we don't lose any data. And this is not a Kubernetes function, but in fact it is a Gartner function that we have in the back end. So we have a backup. If you look at the figure or remember the figure, you will find that there is a backup pod that does this job. Yeah, and then we can also look at the logs to see that the data store have been successfully retrieved. Oh. Basically, this is the backup pod. Yeah. So here we can find restoring backup, and it was restored successfully. It finds the best snapshot and it restores it. Cool. Now let's try to upgrade a cluster. And since this takes time, so we're gonna do it now, and then we're gonna check at the end that it was upgraded. Let's pick the AWS cluster to upgrade. Yeah, so I'm upgrading from 1.10 to 1.11. It's also support feature, so it will be updating. Okay, and now until it upgrades, we can have a look at installing EclipseCon on top of our Kubernetes cluster. So now we have looked at the Garden cluster, the main components, the Garden API server, the controller manager. We looked at the seed components, the scheduler, and all the normal Kubernetes control plane, and the shoot cluster. Oh, we can also look at the shoot cluster. Let's show. Yeah, so the shoot cluster now is containing the VPN Calico as for the network policies, the kubeproxy, and DNS, the DNS pods. Yeah. So basically, this is the network stack. You have Calico for network policies. You have core DNS. In previous versions, kubedns was used instead of core DNS, but now we support the latest versions. And we have core DNS in our shoot clusters as well. There's also kubeproxy that does the IP table mapping, IP table rules, does the complex heavy lifting in the back end to make your services reachable from the cluster. And we have an ingress controller to be reachable from outside. And we have the metric server, which basically be used by stuff like the horizontal pod, autoscaler that looks at the specs from your pods and the specs from the nodes, and finds out whether you need to scale your pods or nodes automatically. And the node exporter exports information to Prometheus to also show it in a nice way in Grafana and so on. So this is basically the stack for our shoot, seed, and the garden clusters. And now we can also do something nice. Who is here familiar with Helm? Helm, okay. So basically, in a very brief term, usually if you want to define or write your own application, you have to define some stuff like services. You have to write deployment spec, pod specs, service accounts, create cluster role bindings, and all these things manually using YAML. And you don't want to do that. And Helm basically does this for you. And luckily, the EclipseCon guys provided a Helm chart that does all these things as well. So they have a Helm chart that I'm going to use. So I'm basically going to say install EclipseCon. I'm going to say which cluster I want to install it on. We're going to find some commands, but that's like the magic. It's creating the service accounts, all the heavy lifting the back end, applying the deployment, and the tiller. Tiller is basically the Helm server that we connect to. And then we're installing now the actual the pods, the services, and everything. And we're defining our ingress domain. The ingress domain is the link or the URL that you are reaching to your application or workload to. And in this case, the EclipseCon. So you see here, everything is installed. It installed services. It created cluster role bindings, service accounts, all these things, simply following a template principle. You have some templates and we replace the values with configurable values. Okay, cool. Now what we are interested in is the pods. First I have to go to the default namespace. Yeah, let's watch on this, because when this gets ready, it means that our application still, the ready needs to be 1 and 1, not 0 and 1. Let's, on the meantime, check. Oh, now we see that it's also upgraded to 1.11.3 from 1.10, so the upgrade works perfectly. Now it's 1 and 1. What we can do is check our Ingress resource. Now we can simply press here. And voila, we have an Eclipse sheet running on a shoot cluster. We can choose, for example, the workspace we want. We want Go, of course, because we write Kubernetes source code. And you can even install or enable some nice fancy editors like Tia. And yeah, cool. This takes time. So I have already another cluster that runs. So we will leave it running on the backend, but we can now see a ready workspace created. This is on a different GCP cluster, the third cluster that we have, that I also showed you. And here we can create a new file. We say, yeah. Okay. Go. This is some nice Java errors in the backend, but it's working.
We told them already.
Yeah. So just writing the, yeah. Cool, let's try running this thing. And it's working. Hello, EclipseCon.
And for that we spin off.
Cool. One last thing I also want to show you is we can even, where do we do it? Yeah, project, import project. Yeah, and we can go to our Gardener repo that you can also go to. And this is basically our GitHub repo. You can go there. It's open source. You can contribute, raise issues, do whatever. File bugs. We want you to. We need help writing code. Cool. So I'm just gonna take this, and of course the other one is still creating, but we are not there. We are in this nice ready one, and we're gonna import this project. Cool. Okay, now we have Gardener, Anshi, and we can code together. I mean, if you can type this whole long link, you can go ahead and we can pair program on Anshi with Gardener. Yeah, I think that's basically it. We can even in the future create clusters from She itself, but it's I think future work. Yeah, that's it. Thank you everyone.
So any questions? Comments?
Yeah.
Yeah, I have a question. How about, for example, if I'm a big company, I have a digital commerce platform, I want to install this application. Can I, for example, I can create my own template, for example, for Google?
We have done this already for you.
Rather than provide this that I can reach, or I can, for example, customize.
Exactly. You can customize all the options. I mean, for the specs that you saw in the presentation. Where was it? Yeah, basically this is how you define a shoot. This is, but we make it nice for you on a dashboard and so on. But you still can use the CLI to do this. But you can customize it as much as you want. You can.
But customize, for example, specific. Suppose I want to deploy AWS in USA and AWS in China is different services provided.
Yeah, this is also from the dashboard. When we create a cluster. There is the regions, but now it's only US one, but you can choose the region you want to deploy
Yeah,
your.
but customize the template, but for example, when you apply by AWS, for example, PPC and something additional features.
That's the question. So we abstract this detail from you,
Yeah,
right?
for me, this is if I can, for example, somehow.
This is customizable from the machine controller manager resource, and if you really require that, you can tell us, and we can easily expose it to this. Yeah, you can easily expose it to the.
So it's just another YAML which can be, of course, tweaked.
Yeah. So
Okay.
it's a setting that we can tweak.
It's not shown in the UI yet, but
What
could
is
be
the
done.
reason why you dropped I'm finished.
Yeah, you can just one last.
What reason why you dropped QDNS in favor of CoreDNS?
Yeah, because well, many reasons. Because kubedns has 3 components, CoreDNS is just 1 component, so maintaining 3 components is much more difficult. So if you look at the pod, you find 3 containers, and I don't know what is happening in the backend. With CoreDNS, it's pluggable. I can put as much functions as I can even write my own plugins. With kubedns, it's not possible. Yeah, sorry, time is up. Thank you, everyone. And if you have any questions, just ask us in our booth. Thank you.
Thank you. Cool.